Good afternoon, everyone. On behalf of the Washington Statistical Society, I'd like to welcome everyone to this year's WSS's President's Invited Talk. My name is Jeff Gonzalez, and I am the current president of the Washington Statistical Society, and it's a pleasure to be here in person and see such a great turnout. Before I begin with some introductory remarks, I'd like to extend a tremendous thank you to the United States Department of Agriculture, especially their executive services team, the audiovisual team, their security team, Linda Young from NAS, and most especially to Darcy Miller, also from NAS, for all their efforts in helping us host this event here today. I'd also like to give a special kudos and shout out to Leanna and Mara from the WSS Social Committee, Amy, our outgoing treasurer, Dan, our current secretary, in coordinating all the logistics and setup for this year's event. So for those of you who don't know, the WSS was founded almost 100 years ago in 1926, and it's the oldest and largest chapter of the American Statistical Association. Our chapter aims to foster a vibrant community of statistical professionals, promote statistical research, and encourage unity and collaboration among all groups concerned with statistical matters. Seminars, invited talks, and other statistical events are just a few of those types of activities that we organize and host on a continual basis to engage the broader statistical community and to meet those aims. Each year, the WSS has the tradition of organizing a special invited talk on a relevant and timely statistical topic. This year, we are honored to have Claire McKay Bowen, a senior fellow at the Urban Institute, and Matt Williams, a senior research statistician at RTI, as the guest speakers, as our featured speakers. Both are experts in the area of data privacy, which is the topic of this year's talk. Data privacy is critically important due in part to the large increases in computational power, the desire to integrate administrative data with survey data for statistical research purposes. As a result, there is an increase of re-identifying individuals who provide data for administrative purposes or as part of standard survey collection efforts. So it's crucial to be able to measure privacy risks and protect those individuals against re-identification. So together, Claire and Matt will discuss some of the data privacy challenges encountered and statistical methods used by the US government and private sector in data collection and data dissemination efforts. So our first speaker is Claire McKay Bowen. Claire is a senior fellow in the Center on Labor, Human Services, and Population, and also leads the Statistical Methods Group at the Urban Institute. I think a congratulations is also in order, as Claire was recently elected as a fellow of the American Statistical Association for an established reputation and her outstanding contributions to statistical science. This is an honor bestowed upon to 1/3 of 1% of the total association membership each year. Claire's research primarily focuses on developing technical and policy solutions to safely expand access to confidential data that advances evidence-based policymaking. She also has interest in improving science communication and integrating data quality into the data privacy process. In 2021, the Committee of Presidents of Statistical Societies identified Claire as an emerging leader in statistics for her technical contributions and leadership to statistics in the field of data privacy and confidentiality. Claire is a member of the Census Scientific Advisory Committee and several other data governance and data privacy committees, as well as an adjunct professor at Stonehill College. Claire holds an honored Bachelor of Science degree in mathematics and physics from Idaho State University and a master's and PhD in statistics from the University of Notre Dame. After completing her PhD, she worked at Los Alamos National Laboratory, where she investigated cosmic ray effects on supercomputers. And with that, I'll turn it over to Claire to present responsibly represent people in data, navigating data privacy challenges in public policy. Yeah, and while Claire gets set up, I want to kindly ask everyone to take a moment to mute, silence, or turn off your cell phone altogether so we can avoid disruptions during this presentation. And we'll also note that we'll be recording this talk and we'll upload it to the WSS YouTube channel in the coming weeks. And finally, after Matt gives the discussion, we'll have time for Q&A and participation from the audience. So with that, finally, Claire.
Right, trying to get myself all set up. I'm almost so shorter, even with heels. That's the tricky thing here. All right. Well, thank you so much for the invitation. Actually, when Jeff's invited me, I was like, does he actually mean me? Does he confuse me with someone else? I don't know, but it's a pleasure and honor to be here to present on my favorite topic, data privacy and data governance. And so just to give a quick overview of what I'm going to talk about, just give some motivation and then some background, because not everybody knows what is data privacy, or at least the area that I specialize in, and what are the challenges, especially in the federal government here, in different agencies, and of course in the private sector. And then going into these kind of 4 pillars that we focus on at the Urban Institute, which is thinking about the accessibility, accuracy, privacy, and usability, and then kind of thoughts for the future work and what I think should be some forward thinking for the field. So first off, like, why should you care? I mean, maybe like that introduction from Jeff made a lot of sense, but maybe some of you are like, oh, I didn't know this was a problem. And actually, that was the response I got from my students. I teach a course over the summer, and many of them didn't know that there was these challenges in the space. And so the example I usually like to start with is that with just like innocent pieces of information, we can learn a lot of things about somebody. So this is actually an article from the New York Times back in 2019, talking about how just knowing time and place, you can infer a lot of information. So in particular, the Times article looked at the fact that you can know if somebody is living in a certain area because they're there during sleeping hours, and where they work because they're there at working hours. So they tracked somebody and finding out that, well, this person obviously lives in Redmond, Washington, and they work at Microsoft because of that information. And then they noticed that the person changed their habit to suddenly going to the Amazon campus for a little bit, and then went back to the Microsoft campus, and then started going to the Amazon campus more regularly. And just that change in habit, they were able to identify this person as Ben Bernoli. So you're like, oh, how did they find this person out? Did they just look in the data to find his name? No, the data was stripped of personally identifiable information, or PII. What happened was that they found his LinkedIn. They just tried to find somebody who had changed jobs in that time period. And so what is to stop maybe like a private company from purchasing data like this and then prematurely firing somebody, knowing that they're seeking other employment? So some people might think, man, that's too much information. We should not share this. But this data is what's used by FEMA to figure out how to, like, the best routes for emergency evacuations. Or right now, if you guys heard the news, parts of New Mexico where I live right now is just experienced a very tragic fire that destroyed over 1,500 buildings. And so these are the things that we need to know, especially in the remote areas of New Mexico, trying to identify where people are and to evacuate them properly. It's also a concern for colleges too. So I thought this was interesting that now there's these apps that you can now know if a student is in the lecture hall, if they're like on time, tardy, or completely absent. You also get information of like when they log in, when they upload their homework, and like when they might be studying. So this could be really invasive, but there was a proposal that this could be used to figure out if students are safe from an active shooter on campus, and to notify family if they're safe, and notify the students like which buildings to go to. So in these 2 examples here, I hope that you kind of like feel this tension, which is the inherent tension that we deal with in this space, which is like, how much information do you provide? Like, at what point do you sacrifice your personal privacy for a public good? And then here, like, why does it matter even more than ever? Because I mean, it's not like these problems didn't exist before. They have been existing for decades or centuries, really. It's happening more than ever because, as Jeff pointed out, there's a lot of push to integrate survey data with administrative data, because survey response rates are rapidly declining. So I'm just going already to the 3rd bullet here, is that their response rates has been abysmal, and it's been across all the federal agencies. There's also the increase of computing power and being able to re-identify people. I believe Jeff mentioned that as well. And then ability to measure privacy risks and protect them is rapidly evolving. So if I asked each and every one of you, what is data privacy to you, I'm guaranteed that all of you have a different sense of what is private and personal versus like what could be used for a public good. This is becoming even more important because then now you have these executive orders from Biden saying like, hey, we need to have better data about race and ethnicity, which requires us to release more information and definitely more fine grain. And I thought that was interesting that then he doubled down again saying like, yeah, we really need this. This is really important, guys. Like, why are you taking this seriously? And part of it is because it's just hard. It's really hard to protect people's information, right? Because just with the example of knowing where somebody is at what time, nothing else, we already figured out who that individual is because of a change in habit. And so it gets really tricky for those who work in the space because you're trying to figure out like how is the best way to match the technology or the technical side with the policy changes that need to be made. And so yes, regulations exist. We have HIPAA, we have FERPA, we have Title 13, Title 16. I'm throwing all these things out, but hopefully some of you know these laws. So I'm backing up a little bit here. So Title 13 being the law that protects census data, Title 26 protecting your taxpayer data, HIPAA, which is your health information, which as a side note, that's your health information through the insurance company, not a health app. That's something I also taught my students. They did not know that it was not protected. So you have GDPR over from Europe and then CCPA from the California privacy laws there. And so we do have these laws that protect us, but they don't always translate over to like these technical aspects that we need to protect people. So then it's not like it's not like these challenges didn't exist before. So just getting some background as to actually like what or how we normally get access to data and why is it not solved yet. So there's generally kind of like three approaches to accessing data. So I'll go over the first one, which is like restricted access. So it'd be nice if you had direct or restricted access, which we have these facilities like SRDCs, which are the Federal Statistical Data Centers. There's these other data repositories that are supported by the NIH. And then you can get access because you sign an agreement saying like, I promise not to do anything bad with this data, right? So hopefully after like signing all these agreements and going through these hurdles, you're like, okay, I can finally access to this data. I can make important policy making. But like in that idealized world, yeah, that would be awesome to get direct access to the data, but not everyone can. There tends to be a lot of hurdles to get direct access. Some of them have eligibility requirements, like being a US citizen, which to be frank, that eliminates a lot of potential researchers. I mean, the majority of the researchers that we're training through our universities are not US citizens. And then sometimes you get through a lengthy clearance process to gain direct access. I mean, I don't know about you guys, but I've gone through clearance 5 times. And it doesn't get any easier. It still takes months or years to go through a clearance process. And so at this point, I'm thinking like, okay, well, if we need to make rapid decision making, we can't just wait months or years to get access to the data. And then finally, it's also difficult to get to a federal statistical research center. So there are 33 currently across the United States. So you kind of think, oh, that's fine. I can totally access one of those. So for those who don't know, I live in Santa Fe, New Mexico. I already said I was in New Mexico, but specifically I'm in Santa Fe. So that is the capital of the state. So the closest FRDC to me is Boulder, Colorado. So that is a 7-hour drive. So how equitable is it that for me to access that data? I mean, maybe urban will let me take that time off to go and try to access the data that way. But all this data is paid for by your taxpayer dollars to be collected by you and for a public good. So in considering the fact that like let's say a community-based organization or some other entities that might not have as much resources, they should be empowered to use that data too and shouldn't be limited to just like I have to drive 7 hours or more to access this data. So that's the first kind of approach, and which is not ideal, especially again for many researchers. And so there's another approach to accessing data, which is like you query or submit a lot of different kind of statistics. And so I kind of like to give this kind of framework for people to give an example of like how one would access data. So you have data users or practitioners, people are like, yeah, I want the data. I want to make important policy making decisions. And then so these are the kind of analyses I want to do. And as a privacy expert, I look at these analyses and like, okay, these are the really important ones. And I try to work together with the data curator to figure out like, well, we want to highlight these aspects of the data in order for people to do these kind of analyses that they want. And so we highlight those statistics. But before we take those statistics out, they have to be altered in some way, usually with what's called the statistical disclosure control or limitation method. So methods of privacy and confidentiality. So slightly altering some of those statistics before they leave that kind of privacy layer in order to become, like, say, summary tables or statistics. So actually in the one that I want to highlight here is like the CDC Wonder. So this is a interactive query system where you can access the latest like information about mortality data down, I believe, to the county level. I haven't checked recently, so I should have done that beforehand. But as a note, that's an example of a more interactive system there. So that's nice and dandy, but sometimes you're like, I actually want to see at the individual level. And this is far more familiar for most people, right? Because when we were trained in school, we were thinking like everything is down to the record level. So then another way is to publish public micro data. So you're going back to this part, but there's a little asterisk on the analysis because you're like, okay, I really need to highlight these key aspects here in order to make a model to generate the micro level data. And so there's kind of a lot of different ways you could do this. And so I like to go through this example here because we can imagine the data set being like a whole painting here. And this is a famous Seurat painting where, if you guys don't know, Seurat is a pointillism master. And so like every little dot you can think about as being a contribution from somebody within the data. And so you have this full picture, but sometimes you're like, okay, we don't need to know every little dot, but we need to know overall that this is people in a park, there's like a lake and some trees and a little bit of sky there. And so there's different methods to protect the data. So imagine that one of the classic ways is suppression. You can remove individuals from the data. So in this case here, I decided to remove the pixels of the individuals who are like some people in the park, because you still get the sense of people in this park. It's a very easy way to protect data, right? You just remove certain individuals because they're just too identifiable. But that becomes a representation problem because then if you remove people who are more identifiable, who tend to be minority groups, then that means their representation is not in the data, and you could lose a lot of policymaking decisions or evidence in the data for policymaking decisions. So for example, back when we had the pandemic, I don't remember if you guys remember, like, wash your hands for 30 seconds, right? To help prevent the spread of COVID. Well, in New Mexico, it's about over 30% of individuals don't have running water. So you lost that messaging on like, how can we help individuals who can't wash their hands for 30 seconds. And so that might have been picked up if we had better access to data and figuring out like alternative health policy plans to help these individuals. Because if you guys remember back when COVID did hit, the mortality rate per capita was the highest in the Navajo Nation, which part of that is in New Mexico, which is was higher than New York City. Another approach is generalization. So you just kind of aggregate smaller groups up to protect those individuals. And so you can imagine like an easy example is education. So instead of saying somebody is like some college, GED, or some high school, GED, high school, some college, associate degree, right? You can imagine all the different levels of education, but you can aggregate it to being like some high school equivalent, four-year college equivalent or less, or things like that, or graduate school instead of saying like what kind of graduate program. So in this case here for this picture, I picked one color of green, one color of blue, and so on and so forth. So you get still an idea of what this picture is, but it's kind of like warped a little bit with the coloring, but you still get an idea. Another one is top coding. It's kind of a version of suppression where you say that a value is up to a certain point, and then you're saying it's that point and plus. So a classic one is age, where individuals who are over the age of 85 is really identifiable. So instead, you just say it's 85 plus. So another way is sampling, because that increases kind of uncertainty here. So generally, actually, sampling came about because it's really expensive to count every person in the nation, right? I mean, that's why census only does it every 10 years. That's why the budget goes way up for them. So sampling is a way to save money, but the thing is that it also helps privacy protection because there's uncertainty of whether or not somebody is actually in the data or not when it gets reported out. And so here, just randomly sampling some pixels. This is actually only a sampling rate of 70%. This was because when I tested for other values like 10 or 20, which is sometimes what you see for some data sets, you couldn't tell what this picture was. So anyways, that's why it's at a higher rate. Another one is that noise infusion. So adding random like values to a particular variable. So sometimes people can think of like age as one of them, where instead of reporting the exact age, you might add a little bit of noise to that. So in this case here, randomly adding and subtracting some values to these different pixels, so lightening and darkening them. So you still get an idea of what this looks like, but it kind of looks like the old TV snow for those who are older and remember the tube TVs with the snow. All right, and then finally thinking about synthetic data. So synthetic data is becoming more and more popular, kind of thinking about like, hey, is there a way for us to pick a model to then generate or sample from that model to create these kind of pseudo records from that model to highlight certain statistical features in the data. And so in this case here, let's just say like, I really want to make sure the individuals in the park are highlighted, but the background can be smoothed out because that's more sensitive or just not as important here. So there's the trade-off in that respect. Oops, I went forward too quickly. So anyways, so then there are obvious trade-offs with this too on publishing microdata. So the thing is that the benefits are it's easier to control privacy loss. It's more familiar, like I said, because a lot of students are trained on having like record level data and analyzing that. It also has less infrastructure needs. So actually going back to the previous example of a query-based system, that's going to require a lot more infrastructure to support that, especially if you have a lot of people accessing it all at once, right? And you can imagine like a server being hit by that. But there are drawbacks to publishing this micro level data. One is being it's harder to capture the use cases. So you can imagine that if somebody is like very loud about like, yeah, this is the use case is super important. So that's like a really loud squeaky wheel, but you want to make sure that you're considering other use cases that maybe somebody is not as savvy with data analysis or just didn't know who to contact. So like, for instance, I grew up actually in a remote area called Salmon, Idaho, where the mayor is the mechanic. And so in that case, there's like, he should also be empowered to use the data to make policy decisions in his town, but he probably doesn't know that he needs to report to a federal register notice, right? To like have his voice heard. So like who's representing him? So there's that kind of issue. It's also the fact that sometimes you just can't capture all the use cases. I mean, 2020 census is a really good example. There's thousands of uses for that data set, but you can't make it entirely perfect. And actually one of the examples I heard from a colleague was that there's a county in Ohio that uses census data for number of restaurant permits. I mean, like, I don't think census is paying attention to that particular use case, but that is one that is being used. And so trying to make sure that the data is useful for everything is, well, impossible, because to do that, you just release the data. So there's that, again, that tension between how accurate should you make the data at the cost of privacy. So it's a less targeted process. And then there is that downstream privacy loss consideration as well for the drawback. So like I said, there's these frameworks, these 3 different ways, but it's still really hard to implement this. There's the thing of like identifying groups and their representatives. And so like, for instance, everybody says like, yeah, we should make sure we have proper tribal representation, for instance. But do people know there's 575 tribal nations in the United States and some of them hate each other? Right? Like, how do you pick of the 575 of them, right? To make sure that their voices are heard. So there's that one. The fact that like determining disclosure risks or utility definitions is also hard. I just told you that you never know what people are going to use this data. And so do you listen to those squeaky wheels, or do you try to dig deeper and find those other unique cases? But maybe the fact that like, do I pay attention to Salmon, Idaho versus LA County, right? Like, how do you weigh those differences there? It's also communicating the constraints and limitations of data privacy methods. So a lot of times when I talk to people, they think that there's a magical way to solve all of our problems, or like have your cake and eat it too, even though fundamentally, in order to have a data set that is perfectly representative of the confidential data, like, or perfectly useful, you just release the data. There's no privacy in that case. The opposite is true as well, that if you want something to be perfectly private or perfectly protected, you don't release anything. And so it's just trying to figure out where is that in between area, which is not linear. It could be like a spaghetti monster or something, trying to figure out exactly how you should alter the data in such a way that balances these 2 things perfectly for different groups, for different definitions of privacy for all these different individuals. It's very challenging. So looking at our approach. So looking at how can we unlock data for informed policymaking while still aligning with our vision to responsibly represent people in data. So these are the 4 pillars, or 4 pillars. We're going to go with 4 pillars. Anyways, 4 pillars. accessibility, privacy, accuracy, and usability. And we're going to go into a few of the different projects that we work at Urban that kind of fall under these categories. Of course, a lot of them do overlap, but just kind of highlighting each of these aspects and particular features of those projects. So first off is accessibility. So creating a system to improve access to Department of Labor confidential data. So one of our big projects here at Urban is that we're trying to resolve some of this problems here. So I already said, like, in an idealized world, wouldn't it be great to trust researchers, but we have these other hurdles, and we're trying to eliminate two of these things. So it's creating a program called the Secure Transfer Restricted Use Data Lake, or Strudel. Side note, I did not come up with this name. And if anybody knows me, I also should never name things anyway, but I cannot claim this. So just FYI. Anyway, so this new program just got launched earlier this year. And so you can find the page. It has a lot of information on, like, how can you get access to this data? What are the kind of expectations? They're trying to be as transparent as possible and make it easy for researchers to access data that otherwise they couldn't get access to. And if you're wondering, like, oh, how do I find Strudel? Just remember, it's Strudel without an E. It's very Googleable. Oh, that's right. I forgot to this page here, which is, we also have some videos with one of my colleagues, like voicing on talking about different statistical disclosure control. So there's a lot of educational materials there too. But again, if you want to find Strudel, remember Strudel without an E, you can Google it. You just might get a little hungry when you Google this thing. I am not responsible for this. Also, as a quick side note, if any of you guys know where a good place to buy strudels are, I've been meaning to try to figure this out because I want to buy a bunch of strudels for all my colleagues and, like, celebrate, like, hey, look, we launched strudel. Found out I can't find any in DC. So if you guys know, let me know. Good strudel place. Okay, got it. All right. I give you guys all homework. Isn't this great? So now going to the other aspect, which is privacy. So thinking about how we can safely expand access to administrative tax data. So I was kind of hinting at this from the question I got earlier. And so this is a collaboration with the Statistics of Income Division at the IRS. And so why is this actually really important? Well, I mean, taxpayer information, that's a lot of information that comes from about individuals and businesses in the United States. And so why Urban is particularly interested in it is because we do micro simulation modeling, or looking at, like, counterfactuals to, like, maybe saying, like, a policy has changed, how it's going to impact the average American. And I have this screenshot here because one of our micro simulation models was actually cited in a John Oliver skit. And I have to bleep it out because that is a swear word. So it's just citing us saying that's an F-ton of money about making Medicare for all. And there we are, Urban Institute on the far right. So we get cited for these different, thinking about different policy decisions. This is why we were really interested in making sure we have access to this data. And so it gets a little tricky though, because it's like, oh, well, you had access before to make this modeling. Why are you thinking about now? Well, because of privacy concerns, as, like, computational power increases, auxiliary information from social media becomes more available, IRS has progressively reduced the amount of information they share. So the thing is at Urban, we're trying to think about two different ways to try to expand access to that data. So I kind of already talked about basic access here, right? Creating a synthetic or a public file, but we're going to make it synthetic. So this is the idea of, like, saying if we can release more information by picking a model and using some, like, adding some noise in addition to, so we can increase some of the variables. So as a side note, one of the key variables that Urban's really interested in is state, and actually future releases of this file has removed state. So that's really important, which is really interesting, right? Like, people in certain areas of the DMV are definitely different than people in New Mexico, right? But they get all mixed up together in that data. So that's really important here. The other thing is like, we can also think about full access, but that's really tough, right? Getting access to IRS data requires being a US citizen and also going through a lengthy process that can be sometimes invasive for some people who are not comfortable going through that clearance process. And so that gets really tricky here. So also the part of the project that we're trying to think of is, like, is there something in between these two means of access? So it's thinking about doing, like, what's called validation server. So maybe somebody's like, hey, I have access to the synthetic data or some other, like, public file, but I know there has to be some sort of jump in this data set here. Like, for, I'm going to totally parrot this, and I'm probably going to get it wrong because I'm not an economist, by hearing jump discontinuity design. I think I parroted that right. Sometimes there's a kink in the data because, like, people I'm not going to quote that. Anyways, we're going to continue on here, but there's a jump in the data there that gets smoothed out because it's too identifiable in the public data, but could be found in the confidential data. And that's really important for decision making on certain like new policies. And so thinking about, oh, what somebody could submit a query to look at that window of that variable and get a response back. So those are the like, kind of the two areas, again, the public file and then the validation server. And so again, going back to my pictures here to help kind of explain this. So we're going back to like how we decide synthetic data. We iterate quite a bit trying to make sure like, hey, like what I was talking about earlier, like holding our sand, right? Like trying to figure out what's the best way to hold it. So it's iterating through figuring out what is the best kind of model to pick. Maybe we need to jitter one area of the data a little bit more because it's too identifiable of those individuals before releasing a data for other people to use. The other one for a validation server is that like is trying to figure out something in between that where like, well, you can't see the data, but maybe that you don't really need to see it because you already kind of have an idea with the synthetic data. And you're like, I want to run a regression model and I really want to get some accurate coefficients with some standard errors across it. And so you submit your analysis to this interface that's like, welcome to the validation server. So you submit that queries and then the analysis goes into the confidential data, you get some of your statistics before coming back to the user. Oops, that's my drink. All right. Before it comes out, you add some little bit of noise, right? Because you can't give the exact results because of privacy concerns, and then hopefully get the output to the data users. So that's like very high level here. This project is massive and there's a lot of challenges that we're trying to face. This project has started since 2017 and I joined in 2019. So you can imagine like it's been quite a bit, but it's an honor to work with all these individuals and my colleagues here. And so because of this massive project, we had to break this up into 3 parts across, say, 23 individuals across 5 institutions. And so we have a synthetic data team, an infrastructure and defining privacy team. So that sounds really weird. What that basically means is that those 2 other pieces are focused on the validation server, trying to figure out like what infrastructure needs are to support such a system. You think of like the security of like making sure somebody doesn't hack into it, they're not going to put malicious coding in and things like that. Versus on the defining privacy side, we're trying to figure out like what is the methodology of like what kind of privacy preserving technology or privacy enhancing technology. So sometimes you might hear pets. So that's what people are referring to. It's like what kind of tech in there should be implemented in the validation server to protect people's privacy. And so here's the QR code if you want to check out this project. It's, like I said, very massive and we've been doing more dissemination. So check it out. I'm gonna pause and sing. And I don't know why I'm singing because I already said I'm a bad singer. And we're gonna keep going. All right, so I'm gonna highlight a few things from the defining privacy side because that's actually the part of the project I lead. And so it's interesting trying to figure out like, okay, what is actually needed when you go to a validation server? So I said like you want to run a regression model and you want to make sure you have these coefficients that come out. And you can imagine that like, okay, I want to make sure these coefficients, are the right sign, significance, things like that, right? We also looked at some summary statistics too. And so it was amazing. I think it was great that we actually got this published in JASA, or the Journal of American Statistical Association, this work. So we did look at differentially private or formally private methods, looking at the summary statistics and some regression. We tested on 2 different data sets. And so the one data set I want to really highlight here is that we made sure we tested on a data set that other people can run the analysis on too. It's really important thinking about transparency about the work that we all do, right? So nobody can access or I say nobody, very limited number of people can access the IRS public file. So I actually forgot to mention this. It's called a public file. It's not that public. There's only like a couple dozen entities that have access to this file, like Urban Institute's one, Brookings, I think New York Times has access to it. You have to sign an MOU and pay $10,000. So it's not that public at all, but it's called a public file. Anyways, so side note there. So not everyone had access to this data. And so in order to make sure that others can like test our analyses, we also ran it on a public data set. So the current population survey and annual social and economic supplement. We evaluate on a suite of utility metrics, like I was mentioning earlier in a question I received. It's like you want to look at a suite of these as best as you can. And then thinking especially in the context of tax policy publications, we kind of asked a few of our tax policy experts on what kind of analyses would be considered. And then noting which methods work in theory versus practice. This is actually a really big thing in my field, is that there's a lot of things to propose in theory. They do not work at all in practice. And so I'm just going to get into the punchline here because we can't go into the full details. So we called it a feasibility study, and really it became an infeasibility study. So our findings show that a validation server is feasible for simple univariate statistics, but really struggled with the accurate regression estimate. So it's really crazy. So the punchline being here is that we only found actually one method that satisfied our criteria for releasing coefficients from a regression. So that was really tricky, but we did like a Frankenstein kind of methodology to expand out to 6 methods, more details in that paper. And we also found that even the best methods consistently, like to recreate sign and significance of the coefficients, even for large values of epsilon. So for those who don't know what that means, it's that we try to crank up the accuracy as much as we can through these methods, and it still wasn't working. So you can find more details in that paper. Like I said, this is a talk, and I don't like giving too much mastering talks and try to go high level. So the follow-up from this is that, okay, so we kind of had imaginary like what we thought was useful, but like what is actually the threshold for people's tolerance for error? So that, as a follow-up for this, we decided to survey the American Economic Association and figure out like what is their tolerance for this. And so this was a convenient sample size, or sample survey. So it was amazing. Considering we did not offer any money, we still got 1,000 responses. So I was like, yeah, that's really cool. We had kind of 4 sections in this survey, asking demographics, research methods across sectional data. So like what kind of methodology they wanted to apply, their knowledge and perceptions of privacy methods. This is really important because if you want to do something new in releasing data, you actually have to make sure that the dissemination and the adoption of it is smooth too. So like, how do you communicate these new ideas to your audience here? So, and then also thinking about the query or error tolerance from the statistic, like what is their threshold? And so we did, in the full paper, you can see like we full disclosure of like it's the American Association of Public Opinion Research, APOR, has some standards of how you describe survey research. And so we hit all the transparency initiatives, including talking about the completion rate, which was 85%. And this is to appear in a special issue of Harvard Data Science Review. So punchline here, what did we find? We found that economists want to perform statistical inference using a variety of regression-based methods. So some of our colleagues in Tax Policy Center thought people just want to look at kink design or jump discontinuity and all those ones. Actually, a lot of people are just like, I just kind of want to do a regression model. So that was nice to hear, because some of these more advanced methods aren't available for privacy methods. Another thing is that these queries that exist with low but measurable privacy error tolerances. So it was interesting that like people who it's like, I don't want very much noise at all. We even asked like, do you have a different standard for your work versus peer reviewed journal work? We actually asked that too. Not much difference. So everybody's just like really, really small error tolerance. And then Goldilocks budget. So we did ask about like how somebody might use this privacy loss budget, quote unquote, how to spend their privacy bucks, I guess, on certain analyses. And they want to have one regression coefficient with robust checks to that. And then another follow-up to this whole thing. This is a very recent paper that my colleagues published looking at like, okay, so now we tested out that there's not very many methods that satisfy certain needs for people for privacy analysis for regressions, but then maybe we don't have the right tolerance level. So we did that survey, and now follow-up is like, well, how should we start assessing these methods? Because a lot of times in the field, we talk about how like, oh, is the prediction really good? Or this usability is really good. So or a particular metric for usability. So in this paper, we're developing a framework for simulated data. So you make the simulated data and then you evaluate the different privacy methods to see if like the inferences are working out for like a known population of parameters. And so we also look at like violations of assumption for, let's say, there's several methods in the privacy space that assume like the data is from normal errors, and that's sometimes not the case, or it's normally distributed, which is very much not the case in tax data. And then also trying to figure out like if we can implement this being more user-centered benchmarking. So there's a white paper out right now. We're working on making full publications soon. So I promise I'm going to get to the end of this particular project. It's a massive one. I told you, I've been on it since 2019. So summary of these takeaways from that particular project was that the simulated data plus bias, like looking at the coverage, effective sample size, that's actually a big thing. There's not a lot of papers talking about that. For our simulations, we found that the Laplace mechanism, for those who know about the Laplace mechanism, has a little bias and good coverage. There are some interesting aspects of violation of multiple linear regression assumptions. So I realized I jumped the gun here. So the methods that we test were actually from that feasibility or infeasibility study, just like as a first test to see like how this benchmarking would work and seeing like how these methods would hold up. Results are sensitive to privacy loss budget. That privacy box is like how much you want to spend to get an accurate result. Looking at signal to noise ratio and bounds on place on the data. And then we did benchmark against the needs and expectations of users, again, going back to that survey of the American Economic Association. Okay, finally, I'm done with that project. You guys are like, oh, thank God. Anyway, moving on to the accuracy. So thinking about how we apply equity awareness in privacy processes. So a particular project here is the publication of a report with a colleague. We called the Do No Harm Guide, Applying Equity Awareness in Privacy Methodologies. So this motivation is going back to, like you saw these pictures earlier, it's like there's a lot of conversations about equity and privacy, but less about equity in privacy. And so what we decided to tackle it was like how would we frame around having these conversations and making sure that equity is in the privacy process. So, but there were some caveats to our guide. First, it's very high level. There was actually a lot more qualitative work than we imagined, very exploratory and hopeful. We're hoping that it's foundation laying, we'll see. And recommendations are very aspirational and will take a lot of work. So those are the things that we realized when we published this report. And so just kind of background is like, why is it called Do No Harm? It's volume 4 in the series of called Do No Harm guides. So colleagues of ours have created one for data visualization and accessibility. There's actually 6 now, I think, because the 5th one is about LGBTQ+ and like making sure those individuals are represented in data collection to all the way to the dissemination process. The background for this report is also targeted audiences, those who are familiar with statistical data privacy methods. So it's not like an entry level, but close enough in a sense. And then we did include a literature review, mostly CS papers, because we realized the literature has only gone back so far and it's predominantly been in the computer science field. We did interview 9 experts, trying to range from a policymaker all the way down to a methodologist more in theory. And we did some illustrative examples to show the impacts of these different methods. And so shout out to our colleagues here. Thank you so much to all of them for like putting up with our questions and to kind of dig in some insights here. And so just to quote one of them, it's interesting that this came out, which is like, what does equity mean? Like equal utility or equal privacy loss? Because there's multiple ways of saying equal, because like the example that our colleague here, Session, was talking about is that in the data set, she doesn't care if somebody knows that she's female, but if she was in a data set with somebody who is non-binary, they very much care if their gender is revealed, right? And so even though you don't care, somebody else might, and just trying to figure out like what does equal mean for different individuals. And so actually going beyond that, we realized that through these interviews in the literature that there was definitely different ways of defining equity. And so thinking about disparities in privacy laws, to how like resource allocation, related processes, so on and so forth. I can't go into all of these, but these are all the things that we kind of highlighted in the report that I found really interesting. In particular, I thought that it was interesting for this number 6, which is misalignment of equity efforts. So quoting a colleague from RTI, I like this one a lot because if equity wasn't considered in the design of the study, then it's not the main purpose of it. Other parts will take priority. And after all, what was the design of the study for, right? So it's thinking about how people say like, oh, we want to make sure that people's gender identities are properly represented. But if that wasn't in the part from the very beginning of how you're going to survey people, then it's going to be an aftermath later on. And so again, thinking about like, how should we consider integrating more granular data? I mean, that was Biden's executive order. It's like we need more granular information, but we need to think about that from the very beginning in the data collection process and having those conversations of privacy and equity early. And so also thinking about how another punchline is that we should not treat equity and privacy as separate studies. That was actually one of our colleagues saying that like what he's saying in the computer science field is that some computer scientists are like, well, my colleague works on equity. That's fine. I don't need to work on it. It's already being taken care of. That's not the case. We should all be thinking about equity throughout all of our research from the beginning to all the way to the end. And so from this, we created like what we call an equitable workflow. I'm not going to go into details of this, but it's very much aspirational because we think this would be great if we can implement it, but it's harder, it's easier said than done. And so one of the things is that we submitted a proposal, hopefully it gets funded, to actually work with some colleagues over at LBN. That's a community-based organization in Austin, Texas, that helps provide food resources to Spanish-speaking communities, because they would like to gather more data about those individuals to figure out how they can best help them, but there's concerns about the immigration status. And so working with them to go through this process and see if there is a solution that will work for the needs of this organization and the people that they're trying to help. And so these are other highlights of the report. I think I'm just going to speed up a little bit given that we had technical difficulties, and so respecting time. But you can see here again, no methodological silver bullet, guys. There's not one solution. So again, I'm going to, for a second time, I'm going to keep speeding up. Is that all right, Jeff? All right, so thinking about usability. So one of my colleagues who is actually in the audience here, thinking about how we can develop open source code to generate and evaluate synthetic data, because it's actually a steep learning curve, right? Like you usually need somebody who knows the mathematics and is a good coder, right? To implement this. And like, how can we actually empower people with tools to do this? So you don't need to know how to build a bike in order to ride a bike, right? So we're going to try to make as many bikes out there as possible for people to ride them, and maybe teach them how to ride them, but empowering them to do so. And so that goes into communication and education aspects of like, how do we communicate these ideas? How do we help empower these people? So one of the things we do is do trainings to let people know there is a trade-off, what are their options, things like that. It's also going into that computation and human resources. So like one of the projects we work on is with the state of Nebraska, where they have the computational resources, but they are just not empowered with like knowledge of these privacy methods. And so how do we make sure that their staff are skilled up so that they can synthesize data? So again, quickly going through, we're developing a type, I say we, it's really others in the group who are doing this, developing the design of what's called tidy synthesis. It's based in tidy models, which is in R. So it's going to be open architecture, and we're slated to publish this next year. So it's been used in a lot of different applications. So I mentioned state of Nebraska, but we also used it for Allegheny County for their human services data. We're synthesizing courthouse data. We're working on a project to synthesize the survey of earned doctorates, taxpayer data, and there was a kind of incubator project too that this data set has been used for. So again, sacred time, we're gonna just punch on through, but just highlighting, it's really important to communicate work. All right, future work. I'm gonna wrapping this up here. So concluding thoughts on what you can do. So the need for data sharing is growing, and so are the risks. So just kind of keeping these in mind and just thinking about that there's not one way to share data. There's multiple ways, and that we need to consider all of them and figure out what is the best option for the users. Effective communication and education is key though in that respect. So somebody asked me like, what is one thing you would fix in your field? And I was like, I would fix the fact that we would have a common taxonomy. Like it drives me nuts that I'll say one term and mean something completely else to another person, because our field is very mixed with different individuals. So like I think computer science is definitely the biggest one. Next is statistics, maybe economics, and then it falls off a cliff after that. But there are people like demographers and other social scientists are involved in the conversations, but we all have different terms that all mean the same thing. And so it's kind of frustrating that we can't cross-pollinate our research because of that. And so it's also the fact that most undergraduates don't know that their data is altered, right? Like it's actually interesting when you talk to people and they're like, oh, I didn't think census data was altered. It's like, yep, it is before you get released. And so we should be incorporating it more into our curriculum to explain like that the data is altered and that there are privacy considerations. Going back to there's no silver bullet. So then I'm going back to the other parts, which is the thing is that there's been a lot of focus on the theory, but we need to figure out how we can translate the theory to applications and ultimately deployment, because there is a lot of code out there, but a lot of it is like research code, right? Instead of like development code or like our product code, right? To like for other people to use, because that was actually an issue for that feasibility study, was that finding out most of the code was not actually implementable. It was actually really tough. So this means that you have to advocate for that kind of research, but that tends to not get funded. So that's been a big issue for me at least. And then again, finally, do not treat equity as a separate field of study. So with that, thank you so much for listening to my talk, even with the technical difficulties, and I appreciate that.
Well, thank you, Claire, for such a great talk. And now we have our discussant, Matt Williams, a senior research statistician from RTI International. For over a decade of federal service and thousands of hours of additional consulting and research, Matt Williams has sought to bridge disparate communities in the federal and international evidence-based landscape. Examples include connecting the survey research and Bayesian statistics communities, bringing optimization and advanced modeling into production of official statistics, developing a research agenda for privacy for survey statistics, teaming up with the evaluation community, and right-sizing solutions for developing countries. Since joining RTI in 2022, Dr. Williams has reached across disciplines to progress innovation, initiatives, and the development of staff related to data privacy, data monetization, and complex Bayesian models. Dr. Williams provides senior technical leadership on large-scale data collection and analysis programs. Matt succeeds through a combination of excellence in research, management of technical operations, and interpersonal relationships. So with that, we'll turn it over to Matt.
Thank you. Thank you. I'll have this, see if I know how to operate this as well. The big green button. Okay. Thank you. This is a tremendous honor. Some of you know my first job was with Department of Agriculture at NASS, and just being in this auditorium is really awesome. It's a special moment for me. So thank you. So as a discussant, I kind of can talk about whatever I want. So first, let me start with thank yous. Thanks, Claire, for a great presentation. Thanks for being a role model in the field and a great colleague. Thanks to WSS and Jeff and team for inviting me. I also want to shout out to my colleagues and collaborators over the years who have supported work in the privacy space. Terrence Savitsky and the Savitsky Lab, Monica and Hong, and colleagues Christine and Nando, and also my RTI colleagues. And actually, I got a text from Janaki Bose wishing me luck, and so I'd be remiss in thanking her for introducing me to privacy about a decade ago. Okay, so here's some confessions. I sometimes wince when people call me a privacy expert because it's my third job. Privacy and public policy are overwhelming. You saw all the content that Claire was covering. That's her full-time focus, right? It can be overwhelming. So many of us juggle lots of responsibilities, right? Running surveys, processing data, running statistical models, but we also have to care about privacy and confidentiality. So again, full disclosure, I'm a little intimidated, a little jealous of Claire, but once you get to know her, she's awesome to work with. So why am I starting off with kind of these silly things? Why am I saying these things? Well, we need a diversity of thought and life experience. It's not a one-size-fits-all solution. We need to really be bridges to other fields and bring in all these different ideas and perspectives. And so sometimes it means putting yourself out there, telling a joke, making a bridge with another community. Okay, so a couple topics I want to talk about, maybe not super well organized. I want to first start off with data access and analysis. So when we think about the analysis pipeline, we start on the left with, we'll call raw data, and we perform an analysis, we get an output, right? An example of that would be we have a categorical response, we maybe want to do a classification or logistic regression analysis, and our output is the predicted or smooth categories, right? If we have a privatized pipeline, we have different places that we can insert a privacy protection. We can do it at the data level before our analysis. We can do it during the training of our model, or we can do it by modifying the output. So those are kind of the three intervention opportunities that we have. So a simple example would be a logistic regression. So the idea is you have zeros and ones, presence or absence data, and you have some predictor variables. A more complicated example that I'm familiar with, we're working on, is if you actually have unstructured text and you're trying to classify, say, an occupation, and you're using a trained neural network. So the challenge is, how do I decide which step to privatize? A lot of it has to do with available methods. There's a lot of gaps. Each of those 3 steps does not exist for all combinations of data analysis and output, right? Some of it depends on what we're releasing. If we're just releasing a single output, maybe we can just perturb at the very end. But if we have multiple queries, as Claire was saying, we have those privacy bucks, that privacy budget we have to spend. If we don't know how many times people are going to ask us to run an analysis, then perturbing at the end doesn't really make sense. We may even want to release the entire model to someone so that they can use it. So that's informed our decision. We also have this privacy budget. Some steps are more expensive. So for example, if we protect at the very beginning, at the very, very beginning, at data collection, where we even don't have the original data, it's perturbed like the respondent perturbs it for us. Yeah, that's a randomized response mechanism. That tends to be the most secure, the simplest to do. It's also, though, it gets the worst utility usually, because we don't have benefits from aggregating or sort of deciding what our analyses are. It's all possible analyses. Okay, so even that is a simplification, because that raw data isn't really raw, right? There's actually all these upstream processes for cleaning and harmonizing the data that use the data. And so if you think about how many times an individual's record could be used before it even gets to that point of an analysis data set, you start to grow the possibilities of how privacy could be leaking. There's some nice recent examples about privacy preserving imputation. One that's based on K nearest neighbors, and another one that talks about preserving privacy at the imputation stage, early upstream versus downstream at the analysis stage. And of course, if you work with surveys and survey sampling, you also have these implications for informative sampling, knowing something about your population so that you can be a more targeted sample. That also informs privacy, because it's not a simple random sample. You actually knew something when you're collecting the data. Okay, so that's kind of one stream of thought. Another one has to do with data access. So that was, what do you do when you have the data? Now, how about accessing the data? Claire talked about a little bit tiered access, which is very popular. So the idea is people are assigned different access levels based on trust. And there's several control systems that are set up to restrict access and to control how things are disclosed. And in general, that's a really good idea. If you're in like I want to say the IT sector, the IT space, you hear about these zero trust systems. And that's very binary. That's either you have access or you don't. And it's all about, being really careful about giving people access. That doesn't really apply here, because the whole point is to disclose information, right? You want to give people access so they can do an analysis and disclose. So in this system, trust and control systems are usually better than zero trust, sorry. But one of the points with tiered access is there's so many different products. It's not apples to apples. You have summary tables, you have microdata, you have custom regressions. How do you compare the privacy across all of these in a composite way to say, okay, when I put all these together, this is how much information we revealed about somebody? That's really complicated. I've seen a couple comprehensive reviews by, experts, colleagues in the field. It takes a lot of time. You go through all these data products, and in the end, what do you get? You get a category: high, medium, and low. You get the red light, yellow light, green light. It's like, okay, that's the best we can do. One of the complications is, do we capture all the use cases and scenarios? Do we think of all possible combinations of information release and intruders? It really gets overwhelming. One of the appeals of formal privacy, like differential privacy, is it aspires to have a formal auditing process. So the idea is you can enumerate all possible uses of the data, so that in principle, you could say, my data, John Smith's data was used for all these products, and here's all the information and how they're released, and we can bound the privacy. So it's very aspirational, it's very bookkeeping. One of the challenges is agreeing on how to measure that concept of privacy. It's really multidimensional, It really varies by person. And if we can actually agree to a limited set of measures like these epsilon measures, then we might have a chance, but it's not clear that what we're measuring is actually privacy. Another interesting issue that comes up with tiered access is, well, what about all the data that's already been released? It's been protected, but it might not have these formal guarantees. So, how do we might imagine a future state where everything is formally protected. And we have a current state where almost nothing is. So what happens? How do we make that transition? So there's been some work. I like the name pufferfish by Dan Kiefer and colleagues, and some extensions to figure out, how do we come up with this meta framework that includes formal privacy and not formal privacy and reconcile it. And as you might expect, it's messy. So I want to move on to the topic that motivates Claire's talk and some of the work that she's done over the years with individuals and equity. Let's talk about some struggles with individuals and groups. So equalization, if that's even the right term, I just kind of made that up. The idea with equality is that everyone is given the same treatment. So in effect, you can think about it's context ignorant. So if I have no information about people, I just have an enumeration, then the maximum entropy thing to do is give everyone the same amount of effort, of weight. Whereas in privacy, equal privacy means everyone receives the same protection, which can often mean the worst case scenario. And utility, the concept is everyone receives the same benefits from the same data products, so either the average or the worst case. And already you might be thinking that's probably not even realistic. One advantage is this is really easy to operationalize. It's easy to defend. No one gets afraid of being accused of, being racist or sexist or, anti-LGBTQ or anything like that. Just everybody's equal. I'm blind, right? I'm blind to the differences. One disadvantage is that most individuals don't get what they want, and they don't get what they need, excuse me. Want and needs are two different things. Most people don't get what they need. You get too much or too little. And one example is, remember a few years ago, we had those child tax credits. And as long as you filed your taxes, you got it. Well, it turns out I have 4 kids, right? So I got a huge credit. Did I really need that? No. Am I giving it back? No. But the point is, it wasn't really, it was equal, right? It was equal. This can also lead to, your favorite Star Trek quote about the majority and the minority. The needs of the many would outweigh the needs of the few or the one. On the other side, we talk about this concept of equity. That's based on individual needs and characteristics, includes historic societal context. This is what you might call context aware. On the privacy side, that means that we would use information about the individuals to modify their privacy protections. Not everyone would get the same privacy protection. On the utility side, individuals and groups may benefit differentially from data products. That kind of feels like something that's more realistic. The advantage is that we can be more efficient and responsive, and individuals get their voices honored. That just feels somehow more democratic. The disadvantage is it's not actually clear how to do this in practice, because as Claire had mentioned, who gets to be a representative of the group? Who gets to decide or be empowered to do that? And kind of a side issue is that when you use additional information about an individual, that also incurs more privacy loss, because if it's equal, you can set a privacy budget and a procedure without knowing anything about the people. But once you look at the people and you customize their privacy, you're in a sense using more of your privacy bucks. And I don't know that much about physics, but there's an observer effect in quantum physics that if you attempt to measure something like a speed and a position, you end up actually changing it. Another analogy I like to think about is, if people are familiar with survey sampling, is it's an allocation issue. So if you think about equality versus equity, that's kind of like thinking about a representation in Congress, the House of Representatives versus the Senate, right? So the House of Representatives is based on population. So the larger groups, the larger states get more influence. And the Senate is based on every state gets the equal amount of influence. So it's that balancing act of, which philosophy or which organization has more influence. Individualizing risks. So as we know, or hope is, I guess I take for granted that there's a trade-off between an individual's privacy and their influence to evidence or their contribution to evidence. You can imagine the more private an individual's responses are, the less influential they'll be to the policy. There's a lot of statistical tools that readily accommodate individual weights like survey weights or propensity weights. And that allows us to kind of customize or tune an individual's influence on an outcome, either like through an objective function or weighted analysis. So we have a couple papers here through Terence Savitsky's lab and colleagues that talk about how we can do that, how we can insert a weight based on a risk measure to differentially smooth or differentially allocate influence. One of the things I'll note here is that was just based on maximizing utility. So the idea is if we have a threshold for risk and some people are below it and some people are above it, we kind of move everybody to that risk, common risk, and that usually increases utility. But it's really not based on individuals' preferences or needs. It's not sort of aware of that. Group level risks. If we expand from an individual to an entity, for instance, we collect data on schools, hospitals, corporations, they contribute data on individuals, but also on themselves. And often there's privacy protections for their participation too. So just like an individual, we imagine that small groups or rare subpopulations are disproportionately smoothed over. So they also have a loss of representation. And there's a couple examples here. I'm glad Christine's in the audience because I probably picked the wrong ones. There's a NIST and Nexus partnership with the United Nations Economic, I should remember that, UNECE. And they did a synthetic data test drive where they compared all these kind of metrics. And there's follow-up work on that, including this paper below about looking at privacy and bias based on diverse communities data. And the idea is just that when you treat everybody the same, the smaller populations basically get smoothed out first or suppressed first. And talking about my second job here, statistical models, you can use these hierarchical models to increase precision for small domains and groups. It's not a panacea. You're not going to double your precision, but you can improve it. And here's an example if we're talking about intersectionality for depression based on race, ethnicity, gender, and sexual orientation. And the idea is this is just a mixed model, it's a multi-level model, but trying to figure out what the privacy of that contribution is for the individual in the group is kind of complicated. Okay, so why is Claire's work so important? Why is this talk so relevant? Why is this topic so relevant? So this is my last slide, just so you can, or second to last slide, so you can all take a big breath. The need for technology transfer strategy for privacy. So I'll walk through this a little bit. If you go through the horizontal axis is what's technology readiness levels. There's usually somewhere around 9 or 10, depending on what organization you're talking about, what government agency. But the idea is you start out at basic principles, theoretical stuff, you go to the bench top, and then at the end you have these systems that are either deployed in the war zone or in everyday life, in your home, in industry. And what you see is early on you have a lot of investment, probably public, maybe some private, in academic research. And then as you go all the way to the right, you have industry pick things up and really let the economic forces and capitalism take charge. But in the middle, you see that there's this gap where it's too risky. Nobody really wants to take ownership of it. And that's where I think the federal statistical system and the federal government does a great job, because they sort of exist in that zone to generate this public good, to get people over this valley of death. And one of the examples that Claire was talking about where, hopefully I don't get it too mixed up, they're trying to come up with these different privatized ways to do regression, and essentially none of them worked. And one of the reasons was there's been a lot of academic research and people saying, yeah, it'll work. But, you know, Claire and her colleagues are like, all right, well then do it. Let's figure this out. And it didn't work. And so this is exactly the work that we need to do, is to figure out, you know, how to balance our portfolio so that we can take on some risky work so that we can get over that valley of death there. Okay, so some prompts for Claire in the audience. One of the things I find challenging is I'm maybe not as ambitious or hardworking as Claire, but I have a lot of interests and I've worked across a few disciplines. And if I get more than 2 of them in the room, it usually is a problem. So we have this fun paper with Monica and Terrence where we try to combine survey data and Bayesian modeling and formal privacy. And I think we managed to upset each reviewer for a different reason. But I will thank the associate editor for being gracious in helping us get that published. And so the idea is like, how do we get over that communication hump? You know, how do we get more than 2 disciplines in the room and talk to each other? And Claire talked about that a little bit too. I've also found we do like model-based estimation without privacy, and just communicating those complexities like models and errors and uncertainty is challenging. A lot of people still want a point estimate. But they want a nice visual point estimate. So what are some best practices just to kind of use these kind of communication outreach concepts that we have to really get people engaged? The other thought I had is, if formal privacy can't be fully implemented, can we still use what we learned in the infrastructure and the aspirations of this bookkeeping and transparency to take the next step forward? And I'm being a little facetious because I know in certain agencies and in institutions they are doing that. But we don't want it to be a house of cards where you have to have perfect formal privacy at every step, or it's all meaningless. I don't want that to be the case. And finally, can we be objective and context aware? We sort of have this false dichotomy that to be objective is to kind of put your blinders on and to be fair. And can you be fair and context aware? I'd like to think we can learn from other communities like the evaluation community. And I also like to think that privacy is a big global challenge. And are there other things we can learn from, like climate change and how they work together and engage multiple stakeholders? So I think that is it. And I have references for the record when we share the slides, but I don't think there's any point in showing them now. Thank you.